as we were talking about in the previous chapter, that carbonyl compounds, we are moving towards now next chapter, which is actually carboxy compound. I just clarified that in the previous chapter as well, that carbonyl compounds are only two in our syllabus. Carbonyl compounds are only two in our syllabus that contain carbon and oxygen bonds, double bonds, right? And we have just two of them are here, aldehyde and ketone, right? These two functional groups are actually carbonyl compounds that we need to study, and we already talked about this in the previous chapter. Now we are moving towards carboxy compounds, and if we talk about carboxy compounds, so again, these are also two in our syllabus. You need to keep remember they are also containing C double bond O, but this carbon is also attached with oxygen as well. So when you find this type of functional group, so it would be known as carboxy compound. And in our syllabus, we need to talk about carboxylic acid and esters, right? So we have, again, two more functional groups that we need to study in this chapter. And this time, we need to talk about carboxylic acid and esters, right? So first of all, I'm going to do carboxylic acid first. So let's start with carboxylic acid, right? Whenever you talk about carboxylic acid, but you need to keep remember that in carboxylic acid, we should have a functional group which is like this: C double bond O and then OH. This functional group is actually main for carboxylic acid, right? So if you talk about carboxylic acid compounds, so you need to keep remember, first of all, you need to draw this functional group, and then you can put carbons over there. So first, suppose if I'm going to start with carboxylic acid, so I draw displayed formula first, right? I would like to draw displayed formula first, and for this you need to keep remember, first of all, I need to draw functional group. बेटे आपका किसी का माइक खुला हुआ है बच्चों? Anyone of you, आपका किसी का माइक खुला हुआ है? Okay, so actually what I am telling you, I'm saying you that, but whenever you are going to draw carboxylic acid compounds, you always need to draw functional group first, right? So you can see this, I just draw functional group over here of carboxylic acid, and you can see this, that a carbon have 4 bonds, right? So right now it is 1, 2, 3 bonds, and the 4th bond is now right now free. Okay, so I am just drawing for first carbon or 1 carbon, so I am just connecting H over here. So this is the first compound for carboxylic acid. So you can see this, but if you talk about the molecular formula of this compound, so we know that what is molecular formula? Molecular formula is actually a type of formula in which you are going to write down the exact number of atoms of each element. So right now we have carbon 1 over here, we have 2 hydrogens over here, and we have 2 oxygens. So this is the molecular formula of this compound, because it is telling you the exact number of atoms of each element, right? And if you talk about the naming, so we know that how can we name the compounds? For the naming, we should have prefix and suffix, right? So if you talk about prefixes, so they are always fixed. So whenever you have 1 carbon, you can say that it is meth. And right now we have carboxylic acid family or functional group, so we can add suffix over here, which is anoic acid. So the name of this compound is methanoic acid, right? Then we have one more type of formula that you need to keep remember is condensed formula. Condensed formula is actually saying that how many hydrogens and the other you can say that elements are attached with a single carbon. So you can say that it is actually like COOH, and then 1 H is attached on the left hand side. So this will be condensed formula of methanoic acid. And then we have last structure formula, which is known as skeletal formula. It is all about what? The number of carbons. So right now we have 1 carbon, so 1 dot, and this carbon having double bond with oxygen and single bond with O and H. So this would be what? The skeletal formula for methanoic acid. Same as it is if I increase the number of carbon, but so it's again the same thing. you need to draw functional group first. So this is the functional group, bacho. Then if you want to increase the number of carbons, so you can attach carbons over here. So now if you have 2 carbons, so we need to complete the valency of each carbon. So every carbon has 4 bonds, so it needs to be fulfilled by hydrogen. So right now we have 2 carbons, 4 hydrogens, and 2 oxygen. And the name of this compound is eth. It's the prefix for 2 carbons. And now this is carboxylic acid, so it is ethanoic acid, right? And you can see this, that if you want to find out the condensed formula for this, so you can see this carbon having 3 H's and this carbon having COOH. So you can write this as CH3 COOH. And if you want to draw the skeletal formula for this, so 1 carbon, 2 carbon, and on this carbon we have double bond O and OH. So this will be the skeletal formula of ethanoic acid. Then if you talk about 3 carbons, so 3 carbons is like, first of all, we need to draw functional group, then we need to connect carbons over here. So this time we have 3 carbons, so I draw like this and complete all 4 bonds of each carbon. So this will be like this, and we have 3 carbons, we have 6 hydrogens over here, and we have 2 oxygen. And this should be propanoic acid. Because of 3 carbon, it should be propanoic acid, and the condensed formula will be CH3 CH2 COOH, and the skeletal formula will be 1 2 3 double bond oxygen and then OH. Is that right, every one of you?
Yes, sir.
Any problem to any one of you?
No.
Yes, one more thing that I just want to share with you guys is one more type of formula. We know that empirical formula, right? One more type of formula is empirical formula. We know that we need to talk about this as well. And the empirical formula is actually what? Empirical formula is the simplest ratio among the elements. So you can see this, it is already simplest, 1:2:2. We cannot divide it further by the same number of, you can say that any number, we cannot divide it by all these. If you talk about this one, so it is 2, 4, 2. So it can be divided by 2. All can divide by 2. So it will be 2 under 2, 2 to the 4, 2, 2 under 2. So the empirical formula for this one is CH2O, but this will remain same, CH2O2, because it cannot further simplified. If you talk about this one, so it cannot be further divided or it cannot be further simplified because all numbers are not in the same table. So it is already simplified. So C3H6O2, right? So these are empirical formula. And if you talk about the journal formula of this family, so you can see this. How can we form a journal formula of this family? It's quite simple. Whenever you see the molecular compounds, the carbon and the hydrogen, the carbon and the hydrogen, the carbon and the hydrogen, all the time, the hydrogen are double of the carbon. So this should be CN and H2N. Hydrogen are always double than carbon, and also oxygen is fixed. So we can write this is the journal formula for this family. Right, every one of you?
Yes.
Okay, so do it quickly, bacho, and also show me by drawing butanoic acid and pentanoic acid. You all need to draw every type of formula that I show you over here: molecular formula, displayed formula, condensed formula, skeletal formula, and empirical formula. And you all know that these 3 are actually all are structural formula, right? So just do it quickly for butanoic acid and pentanoic acid and send me the picture so I can check you are doing it right or not. So this is actually, bacho, what I'm trying to say is actually dicarboxylic acid. So sometime you would have seen this type of substance as well, in which we have on both sides carboxylic acid functional group. So in these compounds, how can we name them, बच्चों? इसका नाम होगा आपके पास ethane. Because of 2 carbon, it is ethane, and because of 2 functional groups, so we need to consider this dike acid. This is ethane dike acid. And if you want to draw the skeletal formula of this. So it could be like this. Right? So you can draw this in your notes as well. Sometime you can even draw like this. For suppose we have 6 carbons, CH2 over here like this, and over here we have COOH, and over here we have COOH. So what is this? This is 6 carbon. So we can say that this is actually hexane. This is actually what? Hexane dioic acid. You can even mention the number of carbon on which the carboxylic acid is there. So you can say that it is hexane 1,6 dioic acid. Right. And if you want to draw the structure of this, so it is like 1, 2, 3, 4, 5, 6. And on the 6th carbon, we have carboxylic acid. And on the 1st carbon, we have carboxylic acid. Yes, right, every one of you? These are some compounds related to functional group carboxylic acid. Is that right, every one of you?
Yes, sir.
Any problem to any one of you?
सर जो अभी आपने लास्ट में बनाया है वो किस चीज का स्ट्रक्चर है?
ये समटाइम ऐसा भी होता है कि आपके पास जो है 2 कार्बोक्सिलिक एसिड के फंक्शनल ग्रुप के भी कंपाउंड में आ जाते हैं. तो these are actually dicarboxylic acids. If you have in a single chain, you have 2 functional groups of carboxylic acid. Right?
Okay, sir.
Okay, so let's move on. For suppose अगर आपके पास बच्चों ये हो गया, आपके पास कार्बोक्सिलिक एसिड ना, आपको याद होगा कि आपने फॉर सपोज अगर आपको याद हो आपने ओ लेवल्स में भी किया था कि आपके पास क्या होता है जब कोई कार्बोक्सिलिक एसिड होता है वो रिएक्ट करता है किसी मेटल के साथ या मेटल कार्बोनेट के साथ या किसी बेस के साथ. फॉर सपोज राइट नाउ आई एम जस्ट रिएक्टिंग इट विद बेस, सो वी नो दैट इट इज कार्बोक्सिलिक एसिड, सो डेफिनेटली इट विल प्रोड्यूस सॉल्ट एंड वाटर ना. सो इट विल प्रोड्यूस सॉल्ट लाइक दिस and water, right? So this is what? This is salt of carboxylic acid and this is carboxylic acid, right? This is carboxylic acid and this is salt of carboxylic acid, right? So this is actually ethanoic acid because it has 2 carbons, so it is ethanoic acid. This is ethanoic acid and this is what? Sodium ethanoate. This is sodium ethanoate, right? So I just want to show you one more thing over here, that whenever you talk about the salts of carboxylic acids, bacho, whenever you talk about salts of carboxylic acid, they are always known as carboxylate salts. They are always known as carboxylate salt, and you can even mention them like this: C double bond O negative. Sometime in the ionic equations we don't need to show the metal over there, so you can show the salt in this way. And I'm just showing the bond over here, so you can write any number of carbon over there. Right now we have 1 carbon over here in the equation, so you can even write CH3 C double bond O. So this is showing you that this is the part of salt. This is showing that this is the salt of what? Carboxylic acid. It would be important in upcoming lectures, right? So you need to keep remember this, and many of the past papers shows this type of things, so that's why I'm telling you this right now. Let's move on. So we are talking about now the physical properties first about carboxylic acid. So some physical properties of carboxylic acid, right? So if you talk about physical properties, bacho, so carboxylic acids have higher melting point and boiling point than alcohols. If you compare the melting and boiling point of alcohols and carboxylic acids, so definitely the melting point and the boiling point of carboxylic acids are higher with the same molecular mass, right? Because if you talk about carboxylic acid, it has carbon and oxygen double bond and then carbon and oxygen single bond also. So it would have greater hydrogen bonding in it as compared to alcohols, right? So you need to keep remember the first point over here is carboxylic acid have higher melting point and boiling point, higher melting point and boiling point than alcohols, than alcohols. This is the first point that you need to keep remember. And you need to keep remember this is all because pure carboxylic acids having hydrogen bonding can, you can say that with two molecules of water, right? It can form hydrogen bonding with 2 or 3 molecules of water like this. For suppose if I just draw the structure of carboxylic acid over here. So this is C double bond O and then CO, and this is carboxylic acid. You can attach whatever you want to over here, any carbon over here. So you need to understand this, that this carbon is partial positive and this oxygen is partial negative, and also this oxygen is partial negative and this hydrogen is partial positive. So due to this, you can see this कि यहाँ पर आपके पास bonding हो सकती है 2 दफा. So for suppose if you have water molecule over here near this, like you have oxygen, this is one of the water molecule. We know that this is lone pair of oxygen, and due to this it is highly electronegative, and hydrogen is partial positive and oxygen is partial negative. So you would see that the oxygen of carboxylic acid is going to make hydrogen bonding with the hydrogen of the water molecule. And if you talk about the water molecule over here like this, so you would see this, that oxygen is partial negative and hydrogen is partial positive. So you would see that hydrogen of carboxylic acid is also going to make hydrogen bonding with the oxygen of the water molecule. So you can see this, a single carboxylic acid can form 2 hydrogen bonding 2 times, the hydrogen bonding 2 times. And if you talk about alcohol, so it was like a single time hydrogen bonding. So that is why a little bit hydrogen bonding is stronger over here. So that is why the melting boiling point would be higher over here as well. Right, every one of you? Yes, every one of you, is that right?
Yes, sir.
And also the solubility, we know that solubility is also going to depend on the hydrogen bonding with water. So you can say that carboxylic acid compounds are soluble in water. They are soluble in water. But you need to keep remember this, that as the number of carbon increases, non-polar behavior increases, then the substance is no more soluble in water. So you can say that solubility decreases. Solubility decreases as the number of carbon increases, as the number of carbon increases in the chain. Because when the number of carbon increases in the chain, the non-polar behavior of the chain is going to be increases. That is why there will be no more, or you can say that कि वो जो hydrogen bonding होती है वो overcome हो जाएगी, इस type का कुछ कह सकते हैं आप, ठीक है ना? You can say that this is all because carboxylic acid is capable of forming hydrogen bonding with the water molecule when it is in less number of carbons, right? Or you can say that solubility is actually decreasing with the number of carbon increasing because the presence of long hydrocarbon tail disrupts the effectiveness of hydrogen bonding, right? You can even see this, or you need to learn this because this is the main reason. और ये अभी पहले भी आपने इसको यूज कर लिया है पिछले कुछ मॉलिक्यूल्स के अंदर. सो यू नीड टू कीप रिमेंबर दैट, ये आसान है, इसको याद भी कर सकते हैं आप, और ये रीजन आपके लिए मेन है, ये वाला ही याद कर लें आप. लॉन्ग हाइड्रोकार्बन चेन्स, long hydrocarbon chain, or you can use the word tail over here as well, disrupts I use 2 times T, disrupts the effectiveness of hydrogen bonding, the effectiveness of hydrogen bonding. Right, Bacho? You need to keep remember this reason. It would be important in exams. Right, every one of you. Is that clear?
Yes, sir.
Okay, so let's move on towards the preparation of carboxylic acid. If you talk about the preparation of carboxylic acid, so we already talk about some reactions in which we are going to form carboxylic acid. So let's see If we talk about preparation of carboxylic acid, so how can we prepare, or how many reactions that can form carboxylic acid? So preparation of carboxylic acid. So we already talked about in the previous reaction or in the previous chapter, और उससे पहले भी alcohol में भी हमने पढ़ा था that oxidation, one is oxidation of primary alcohol. By primary alcohol oxidation, you can produce carboxylic acid. We talk about this in alcohols, right? And then we talk about in the previous chapter that oxidation of aldehyde can also produce carboxylic acid. So oxidation of aldehyde can also produce carboxylic acid. And you need to keep remember this one, which is the most important one, जो कि बहुत आता है past papers के questions में आप देखेंगे. You can say that acidic or alkaline, you can use any one of them to catalyze a reaction. Hydrolysis of nitriles, hydrolysis of nitriles, ये reaction papers में बहुत आता है, तो इसके बारे में अभी हमने करना बहुत important है, right? इससे पहले वाले जो हैं वो हम already कर चुके हैं. We know that what is oxidation of primary alcohol, we know that what is oxidation of aldehydes. If you not remember this, so let me tell you again. If you have primary alcohols, you can convert this into aldehyde, or you can convert this directly into carboxylic if you want to convert this. And I told you, how can you convert this directly? You need to use a strong oxidizing agent over here. So you can say that acidified, or you can even use only H positive ion over here. KMNO4. You need to use KMNO4 over here, which is a strong oxidizing agent. It would convert primary alcohol directly to carboxylic acid, but the condition is very much important, and the condition is heat under reflux. If you want to stop this reaction at aldehyde, so you need to heat and distill the product, but if you want to complete the reaction, so you need to heat under reflux. And the same thing from aldehyde as well. You can also do this with aldehyde. If you have aldehyde, so you can convert this into carboxylic acid as well. The condition would remain same, heat under reflux. The condition would remain same, heat under reflux. Heat under reflux. And again, acidified, बच्चों, acidified, you can even use over here potassium dichromate, because आप जब अल्कोहल से एल्डिहाइड बनाते हो तो आप पोटेशियम डाइक्रोमेट यूज करते हो ताकि रिएक्शन स्टॉप करना आसान हो, क्योंकि इट इज अ लिटिल बिट माइल्डर oxidizing agent, or even you can use if you want to KMNO4, so you can, right? So these two reactions we already talk about in the previous chapters, right? So I'm not going to talk about this furthermore. Let's talk about the new one. The new one is what if we have nitriles, so the nitriles can convert compound into carboxylic acid. For suppose if you have CH3CN, so this is one of the nitrile, right? You can convert this nitrile into carboxylic acid. You need to keep remember this carbon will remain same, the para wala CH3 will remain same, and then nitrile is going to be convert into COOH, right? This is there are two types of hydrolysis as mentioned over there. Number one is acidic hydrolysis. So let's talk about hydrolysis, acidic hydrolysis first. So if we talk about acidic hydrolysis, definitely we need to use acid over there. So let's add acid over there. Over here we are going to add acid along with water, because this is acids are always aqueous. So this is acidic hydrolysis. So when you have carboxylic acid over there, you must have the other gas as well, which is NH3. NH3 is going to be formed, right? NH3 is going to be formed, and you need to keep remember that NH3 is actually basic. So whenever you are going to do acidic hydrolysis, so acid and base react together and it will form salt. So in place of NH3, you should write NH4 plus over here, because it is the salt for NH3 gas, right? So I just recommend you to write NH4 positive over here, because क्योंकि आपने acidic hydrolysis की है, so ये आपके पास salt बन जाएगा, and the salt is ammonium salt, right बच्चों? because you are using acid over here, right? Every one of you. The condition is
सर
again,
आपने एसिड क्या लिया है?
एसिड आपकी मर्जी, आप सल्फ्यूरिक एसिड लें या आप हाइड्रोक्लोरिक एसिड लें, आप दोनों में से कोई सा भी एसिड ले सकती हैं, any acid. So you can say that dilute HCl can be the condition or reagent, sorry, and dilute hydrochloric acid and sulfuric acid, any one of them can be the reagent, but the condition will remain same, heat under reflux, and the type of the reaction is hydrolysis, right? Right, bacho?
Yes, sir.
We have one more type of hydrolysis, the same thing. We can do even alkaline hydrolysis, means you can convert nitriles into carboxylic acid in the presence of alkaline conditions, right? So it should be called as alkaline hydrolysis, right? So if you talk about alkaline hydrolysis, again, hydrolysis would be the same thing, which is a type of reaction, right? For suppose if you have nitrile CH3CN, right? And in this, what you are doing, you are adding aqueous, right now you are adding aqueous sodium hydroxide, or you are adding aqueous potassium hydroxide, any one of them, any alkali solution you are adding over here. So definitely it is diluted, so you are adding in the presence of water, because hydrolysis is a breakdown of any compound in the presence of water, and we are providing alkaline conditions, so OH over there, right? So when you add these two things over there, so definitely it will produce what? Carboxylic acid and ammonia gas, right? But you need to keep remember that the conditions are alkaline over here. So the conditions are alkaline over here, and the carboxylic acid which is forming over here is acidic. So acid and base reacts together and form a salt. And I told you that whenever the salt of carboxylic acid is going to be formed, so you can show it by this. You can remove H and you can show negative sign over here. So it is showing you that the salt of carboxylic acid is going to be formed, right? And if you want to convert this back to the carboxylic acid, so you can take this out, this salt, and you can add acid over there. So you will see this carboxylic acid is going to make again, right, bacho? This is a further reaction, but this is fine if you do the only first one. And for this, you need to keep remember the condition would remain same, heat under reflux, and the reagent can be aqueous sodium hydroxide, or you can even use aqueous potassium hydroxide. So for the hydrolysis, you can use any reagent over here. You can even use hydrochloric acid, you can use even sulfuric acid, you can use potassium hydroxide, you can use sodium hydroxide, but you need to keep remember they should be diluted, because hydrolysis is actually the breakdown of a compound in the presence of water. So you don't need to be having these acids and alkalis in the concentrated state. You must have in the diluted state, because the water is necessary in this reaction, right? Every one of you, is that clear?
Yes, sir.
And one more thing about this reaction, which is very, very important, that I just want to share with you guys, because in past papers, you would see this type of things in your past papers. And this is very compulsory thing that you need to understand. Just look at over there, bacho, what I'm just going to say to you. That's like this. We have CH3, CH2, and COOH. This is one of the carboxylic acid, which is known as propanoic acid. And for suppose in the middle, I don't have a compound, right? Like this. And over here we have CH3, CH2, Br, right? So for suppose, I am asking that identify X. I am asking identify X, and also then reagents and the conditions for the following reaction. Reagents and the conditions for the following reaction. Over here, this is reaction number 1, and this is reaction number 2, right? So the reaction number 1 and reaction number 2. So, but you need to keep remember this, that what I'm saying, but just look at over here. Just look at over here. How many carbons over here we have? 2. We have 2 carbons over here on the left hand side, and on the final product, we have actually 3 carbons, right? So this thing is clarifying what should be in the center. you need to keep remember that whenever we need to add carbon in the chain, whenever we need to add carbon in the chain, we need to substitute nitriles. Right, bacho? Is that clear?
Right, sir.
So whenever you want to increase the number of carbons in the chain, so you must need to place nitriles over there. So we should do one thing over here. We need to substitute bromine by nitrile. So this should be the reaction, and then it can be converted into this. So you can see this. What I need to do, I need to add NaCN or KCN, whatever you can add in ethanol. You must need to do this in ethanol, because we know that if we are doing this in aqueous state, so hydroxide would be there. So we need to heat under reflux, and over here when we need to convert this into carboxylic acid, so we can use dilute hydrochloric acid and heat under reflux. Right, bacho? Is that right,
Yes,
bacho?
sir.
sir.
So this is the main thing that you need to understand. Whenever in the reaction scheme in your papers, you would see that कि यहाँ पर तो नंबर ऑफ कार्बन बढ़ गया, तो इसको और से देख लीजिएगा, आपको पता चल जाएगा कि हमने यहाँ पर नाइट्राइल ऐड किया. तो नाइट्राइल का काम ही यही होता है. If you want to increase the number of carbon in the chain, you can substitute nitrile over there. क्योंकि देखें ये नंबर ऑफ कार्बन तो अपनी जगह पर है, ये जो फर्दर आपने हाइड्रोलिसिस किए, तो ये जो नाइट्राइल आपने ऐड किया है ना, ये नाइट्राइल एक्चुअली कार्बोक्सिलिक एसिड बना रहा है. तो ये वाले कार्बन तो सेम है, इनको कुछ नहीं हो रहा. ऐसा नहीं हो रहा कि ये जो CH2 था ये कार्बोक्सिलिक एसिड बन गया. CH2 कार्बोक्सिलिक एसिड नहीं बना है, CN carboxylic acid बन गया. ठीक है ना? You need to keep remember this. So whenever in any chain, in any reaction scheme, if the number of carbon increases, so you need to remember this, that it is actually showing what? It is actually showing the substitution of nitrile. Let's see. So for suppose I am just drawing one of the reaction scheme over here. For suppose I have CH3, CH2, OH. For suppose I have CH3, CH2, OH, I just give few conditions to them and one of the compound form, right? And this name is X. And then I just give one more condition to this and the Y forms, right? And after this, I just give one condition to this and A will be formed, right? And I just give few conditions to A and it would form what? B. And then I give conditions to B, so it will form C, for suppose now. So I have alcohol, which is ethanol over there. So for suppose I am just giving condition to it that I am giving it acidified potassium dichromate along with what? Heat and distill, along with heat and distill, right? And over here, again, I am giving the same condition, right? But this time I am doing what? Heat under reflux, right? And over here, what I'm doing, I am doing adding, for suppose, concentrated H, or for suppose I am just adding over here PCl5 at room temperature and pressure, right? And then I am adding over here NaCN in ethanol. And over here, I'm adding dilute hydrochloric acid, right? And heat under reflux, heat under reflux, heat under reflux, right? Yes, so bacho, can you draw the structures of A, B, C, and X and Y? Yes, bacho. Can you draw the structures of A, B, C, X, and Y? Just try this. I'm waiting for your answers.
The structures बनाने